This conference will now be recorded.
All right, thanks everyone for coming to today's test subgroup meeting. Today, Keysight is going to walk us through this BGP convergence test plan. Kama is going to give us present the test plan. Kama, you can take away. Thank you.
Okay, thanks. Yeah. Hi all, this is Kamal Sahu from Keysight Technologies. Today we will be discussing this particular PR. So in this test plan, we will be discussing the BGP convergence, resiliency, and performance testing. So this is the corresponding PR for this test plan, and let's go to the test plan. So in this test plan, we will discuss how a single dot can be used in different topologies, such as switch acting as a TOR or switch acting as a leaf, and measure convergence. These are the list of the test cases which we are going to add it to this test plan and then contribute to the community. Let's briefly go over the test cases. So these test cases has been characterized. Oh, I'm hearing some echo. Can you please mute? Okay, thanks. Yeah, so these are the test. Oh, okay, still.
Anyone who is not talking, can you please mute yourself?
Yeah, thank you. So these are the full list of the test cases, and the test cases has been categorized according to the topologies. So here if we see like this is the one of the topology that acting as a TOR. So these are the corresponding test cases. In a data center, generally the one of the main failure scenario is a link failure. So a link failure can be a local link failure or a remote link failure or a node failure. So we will be simulating those failure scenarios and will be measuring the convergence. So the first three cases will be covering those failure scenarios and will be measuring the convergence. Next test case is, for example, in a network, if a particular device or for example, if you want to upgrade a particular device or to do a maintenance of a particular rack of servers, then we can change the attributes such as the local preferences or the ASPAS of the devices so that it won't take that particular path and instead it will route to that using different path. So we will be measuring the convergence by changing all those attributes. Next test case is the in addition to BGP, like we will be adding protocols such as like LACP and BFD, and we'll be measuring how fast the convergence will be achieved by adding these protocols on top of BGP. Next test case is the ribbon convergence. This is to see like in a network if you want to bring in a new set of rack of servers or any other machines, we need to know like how fast it learns those routes and install in its RIB and then in its FIB to forward the traffic. We will go through this test methodology in detail later. Coming to the scale, we will be measuring the convergence by doing all the way up to like 32-way ECMP and doing these failure scenarios, and we'll be measuring the convergence. Next test case is the route capacity test. So in a network, if a particular rack of servers goes down, so the load increases on the remaining devices available in the network. So we need to know like what is the maximum route capacity that the switches can handle. So coming to the topology like that as leaf, we will be covering all these failure scenarios along with the ribbon convergence and the route capacity test. So any questions here regarding the test cases? Okay, then let's go back to the test plan. So the main objective of this test plan is to measure the convergence by creating the real world failure scenarios such as the local link failure, node failures, or remote link failures, link faults, etc. by simulating multiple devices. So this is the test bed which we are going to use in this test plan. This test bed has been already defined under the community test bed overview document, and this is already being in use for developing like RDMA and or PFC cases. So the test bed server consists of the SONiC management Docker along with the AX network Docker, which in turn will be accessing the test ports and the SONiC DUT. So these are the two topologies which we are going to discuss in this particular test plan.
Hey Kamal, sorry, this is Ben from Broadcom. Can I, before we move
Yeah.
on, just ask a quick question. Go back to your test setup, please.
Yeah, sure.
The key thing is you're planning on using an Ixia chassis for this, right?
Yeah.
Can I just do a quick poll within the community? How many community members are using Ixia in their test setups? Is this everybody? Because it's not in the PTF setup today, right? The standard community test setup. So I'm trying to understand, how widely used is Ixia for community test cases. I mean, I know we use it in Broadcom, but I don't know if other companies do.
Yeah, we are not using like most of the community members may not be using like Ixia or chassis and the hardware, but we started using, for example, for particular like precision kind of test cases in this scenario, like where we need very precision timestamps and all. So we have that capability. Like we
So,
cannot get it using the two other tools, right? So that is the reason why
so
we
I
are.
think, sorry to interrupt, Kamal. I think Ben's question was for the community members, if I got it
Yeah,
right.
exactly. I'm just trying to do a straw poll and just see who's using Ixia in their setups. How widely can this be used?
Hi, this is Taskin. I'm from EdgeCore. We do use Ixia.
Okay. Anybody else?
I mean, I'm Bhavani with Cisco, and we also do have Ixia in some of the lab. So,
Okay, thanks. Kamal, carry on.
Yeah, sure. Thanks, man.
Sorry, Kamal. One quick point. This is Mono from Keysight. We also worked on the PFC test plan, which Microsoft have upstreamed. I think that's also is using the same topology, Ben.
Yeah. Right. I mean, there are certain features where you kind of got to have an Ixia, right? And those are both good examples, I would think, because PFC and a BGP scale test, you need something that can emulate what happens in a real network, and it does make sense. I'm just trying to understand how widely used it can be.
Absolutely. Thanks, Ben.
Yeah, thank you. Okay, so coming to the topologies, so the first topology is this when the SONiC switch is acting as a TOR here. So the SONiC switch is acting as one of the TOR here, and the solid lines represents the test ports which are physically directly connected to the SONiC DUT. So here if we look at like T11, T12, T13, these are all the physically connected test ports along with this server one. So we will be simulating these TOR remaining devices behind these test ports. So this way we can easily scale up to like NVE CMP by simply adding the test ports and then simulating the multiple devices behind those test ports. The next topology is when the SONiC switch is acting as a leaf. Here the SONiC switch will be acting as a leaf, and the test ports here, the solid lines represent the test ports. So the test ports here will be acting as a T2 devices, which is nothing but acting as a spines here. And then in turn we'll be simulating all these multi-layer devices, like for example here this particular switch at the T1 layer along with the stores and the servers. So any queries regarding these topologies? Okay, so this way we can easily scale up to n-way ECMP and then we can do our testing. Coming to the setup configuration, like we will be eBGP pairing will be established between all these devices, and we'll be simulating these devices and we'll be advertising like IPv4 routes or IPv6 or dual stack routes. Coming to the test methodology, let's go through the test methodology while covering the test cases in detail. So I'll go through the couple of test cases in detail. The first test case is to measure the failover convergence by simulating a remote link failure. So for better understanding and for simplicity, just here we are considering a two-way ECMP. In order to do a two-way ECMP, we will need 3 physical ports. Like here we are using, like this one is a test port, physical port, and this T11 and T12 are the 2 physical test ports. And we will be simulating these devices behind these test ports and will be advertising the VIP addresses. In general, like services such as these load balancers or firewalls will be running on multiple devices and on different racks. So we are trying to simulate that particular scenario here where we will be advertising the same VIP addresses from these devices. So initially, for suppose like we'll send traffic at 100% of the line rate. So initially we'll send traffic from this particular server to these VIP addresses. So as ECMP is running here, we will have 2 paths. So for example, the green path which goes from T01, T11 and T02, and the second path is T01, T12 and then T02 to S2. So if you see the diagram here, so when we send at 100% of the line rate, as we have like 2 flows here, flow 1 and flow 2, so we will be receiving traffic at 50% of the line rate. At a particular instant, for suppose here we will create a failure event. Here we are creating a remote link failure. So in order to do the remote link failure, we will be withdrawing this route from this particular device. So when we do that, so this particular switch will learn that, okay, this path is no more available and it will route the traffic through this red path. So here we can see that the green path is going down and is not receiving any of the traffic, and the red flow will start receiving all those packets. Here we will set a particular desired threshold value. Here we are setting it to, for example, 90%. So that means like once the particular flow goes above the 90% of the line rate, we will measure a timestamp here. So the difference between these 2 timestamps will provide us with a CPDP, means which is nothing but a control plane to data plane convergence value. Here we can set it to any of the desired values. So any questions regarding the test methodology for this failover convergence?
Yeah, I have one. So
Yeah,
we're trying to measure the performance of the DUT, right, which is the blue box, right? Now, what I think this test is doing is we have a failure event, and I'm not sure why that is because there's some delay here, right? If say it was a link event, then there's another thing in this path which is basically the T1 router doing that link detection and then withdrawing the route. So isn't that going to get counted in our convergence time? Right? How do we isolate what actually happens on the DUT?
actually when we do a route withdraw here, in turn this first switch will learn and in turn it will propagate to this particular device, right? So it will be the overall convergence within the network, and we will be measuring that and we'll be providing that convergence value.
No, I get that, but what I'm saying is really it's kind of an unfair test because there's other delay in there that we can't control. Do you see what I mean?
So let me add to that, Kamal, for a second. So since this T0 is emulated behind the port, behind our test ports, right? So the delay, it's essentially there is nothing as a link. Those dotted lines between T1 and T0 are all emulated links, right? So there is no delay on propagating the the routing here, like the event from let's say S2 via T0 to T1 back to T01.
Right.
So we can, I mean, essentially what I'm saying is the whatever is happening in the dotted emulated path is kind of instantaneous from the test ports, right? So the event, as we start withdrawing the routes from the BGP, and when T0 starts to learn that the path has gone down, it's kind of instant. So essentially, we can think of it's all about the T0 being converging path.
Okay. So I think what you're arguing is that the delay isn't real, right? Because this is all emulated. Because really,
Right.
the failure event as far as the DUT is concerned is, I guess, when it starts receiving the BGP route withdrawals, right? That's the failure event as far as the DUT is concerned, because it doesn't see anything else.
Exactly.
Okay, all right.
Okay.
And
Any other?
just sorry,
Yeah.
one follow-up comment here is obviously this is the first topology that we are saying that, hey, this is a single dot topology. A more realistic test in a system test would be like if those emulated dots, if you put more real switches in there, and we can do a lot of more system-like tests, right? So right now, since community has a single dot topology, we are trying to as much as emulation that we can take and have those realistic scenario covered through a single dot is what we are trying to do here.
Yeah, makes sense.
Yeah.
Yeah. So later in our call of action, like we had already defined, like we will be replacing the simulated devices with the real dots in case if you want to go at the system level, and we will be doing these applying these test methodologies, and we'll be measuring the convergence. Yeah.
Actually, are you sending traffic from T0/1 to the 0/3 as well?
Oh yeah. So here also there is one more VIP addresses where we will be sending like to this. So yeah, we are sending it to S3 as well.
But you only measure this T01 and that's T02, right?
Yeah, for now this is the flow which we kept down, right? So there won't be any change on this particular one. So for this particular one, we will be receiving this particular because the same routes are being advertised from this particular device. So we will be distributing or changing the traffic between these two paths, only
Okay.
like this path and as well as this path.
Okay. Yeah, because it's not very clear. Like
Yeah,
in
for
the
the
right picture, you said test port 2, test port 3. I don't know which one is 2 and which one is 3. The right
okay, so
picture.
this one, the green path shows the test port 2, and the red path shows the test port 3. Because S1 is acting as a test port 1, right? So this is test port 2 and test port 3. And this is the flow corresponding to those flow test ports.
But you
So
have traffic. But you have traffic to the 0/3 as well, right? You cannot be 100% or 0%, right? Okay, you're only talking about the flow, not talking about the physical.
yes, actually, correct.
Yeah, I think this measurement is only happening on S2, right? That's the only place.
Yeah, S2. Yes, we are measuring on S2.
Okay.
Right.
It might be valuable to read which ones are simulated, which ones are real duties. Like the T0-1 is real duty, isn't it, right?
Yeah, this is the real duty. Here we can see that these are the emulated ones, these two, and these are the real test ports.
Okay, so both the red ones and green ones are emulated ones.
Yes.
Yeah, everything here is emulated except the DUT, the single box T01, right?
So the simplify, I think you can completely remove the 0/3, right? You're not using it.
Because in the next diagram we are going to cover that actually, so that is the reason why we wanted to show that particular path as well. For example, like here there is one more scenario which we are going to cover, so that is the reason why.
Yeah, okay.
Okay, so any other questions here? Okay, let's move on. So these are the benchmarking performance results which we got for this failover convergence by advertising this set of IPv4 routes. Okay, so for the above test case, if we do a multi-link failure, for example here, that is the reason why we are having two flows here. So one flow is from S1 to S2 and the second flow is from S1 to S3. And each of the flows will have like two paths. So here again the same path like T01, T11 and T02, and the second path is T01 to T12 to T02. Same for the second flow like S3. Here there are two flows here, right? So we will be withdrawing the routes of these two links, and then this particular switch will learn like those paths are not available anymore, and it will be using the red path in order to forward the traffic to these two flows. And these are the benchmarking performance results for this multi-link failure scenario by advertising these set of IPv4 routes. Okay, so going to the next test case. So this is the ribbon convergence. So as already explained, like whenever we want to add a particular rack of servers or devices into the network, we need to know like how fast it can learn and install in its RAB and then in its FAB to forward the traffic. So we are again taking the same topology.
Sorry, you should step into a new scenario right now. So if you go back to the previous scenario, so the first test case is that you have a single link failure. The second case is that you have the multiple link failure towards the same T1. Will that be interesting to have another scenario that, let's say, T0-2 has a failure with T1-1 and T0-3 have a failure with T1-2 instead of they both have failure towards T1-1? Will that make a difference?
Yeah, we can do that. Like this is kind of just two samples which we are trying here, but we will be covering all those different scenarios in our all those test cases which we have listed, right? So in that we will be covering those scenarios as well. But for just for this particular presentation, we are just covering these sample test cases. So definitely we can add that particular scenario where we can do link down on one of these other path actually.
Yeah, Ian, that's a very good suggestion. Since this is all simulated, BGP router and advertised routes behind the hardware ports. So in theory, you can go through these different combinations of exercise, withdraw routes to hit different part of topology, and then characterize the convergence performance. I think that's exactly what these tests is going to expand it to give us more coverage and more variations of scenario. Right?
But Dean, I think Ying's point is you also want to test where the link failure actually happens on the hardware ports connected to the DUB, right? Because that's an alternative trigger for ECMP failover.
Yeah, so that is like a local link failure. So
exactly,
the first test case which we mentioned was a local link failure. So we will be doing that when we do a local link failure. These are like we are simulating the links.
Cool.
Yeah,
right.
That is the reason why.
Yeah, I think that there are basically three types of failure that could affecting the device onto test. A device onto test is a single device. Either you have a local link failure or a remote link failure that appear as a route withdrawal, right, for the DUT perspective. And the other one will be the node failure, right, which we are not showing here. That basically was just killing one of the router. BGP router just go dead and no response. So those are kind of a three common types of failure we can effectively emulate and apply different topology for testing.
Okay.
I have a quick question here.
Sure.
So you have like these two link failure here, right? So when you say withdraw routes 1K, does that mean like you have 500 here, 500 there? Or What is
No,
this
we will
1K?
be advertising like 1,000 routes. So overall, for all the 1,000 routes, we will have like two parts. Like both of them will be learning all these. Like for example, the test ports will be advertising all those same 1,000 routes here, so that it can the SONiC dot will know like, okay, in order to reach this S2, these host prefixes, like I have like two paths. So both these test ports will be advertising the same
No,
1K.
but you have traffic to T03 as well, right?
Here for T03, we have one more 1K flow.
So you
There's
have a separate,
passing as well.
you have 2K flow. You're saying you have 2K traffic, 2K routes?
Oh, okay. Yeah. So for this multi-link scenario, we have 500, 500 here. For like single link failure, we have like 1K here.
Right. Okay,
Yeah,
that's my
yeah,
question.
yeah. No, yeah. Thank you.
And basically, just to add, right, so you can play around with the routes here, right? We are not fixing the values here. It's going to be parameterized, right? So this is a benchmark test. Consider this to be kind of an RSC 2544, which you can always run it through iterations and binary search and number of values, like depending on the ASIC you're running on. And as you see, like we kind of characterized a few number of routes to see how the convergence time is affected by the number of routes. So we do see some variance here, obviously. But if there is some definitive benchmarking number that the community wants to do based on the number of routes versus the convergence time, that can be easily plugged into this test case.
Yeah, understand.
Yeah.
Just want to clarify those routes.
Yeah, sure.
This is
Thank you.
Yeah, absolutely.
Yeah, let's go to this ribbon. So we are here using the first topology, which is the switch acting as a drawer. So here this is a SONiC switch, and will be like initially when we send traffic, like for example, flow from S1 to S2 or S3. So we will not be advertising any of the routes initially. So in that case, when we send traffic, we will see like nothing, no packets will be received at this flow. So we will see like at 0%. And at a particular instant, for example, at this instant, we started advertising these routes. So like, for example, S2 and S3. And we will note down the timestamp. So if you consider only S2 here in this scenario, just for a better understanding. So once we start advertising the routes, it starts learning those routes and then install in its RIB and then in its FIB. So the flows will start receiving the packets, and we will set the threshold value to a desired value. Here, because we are setting it to 45%, because as ECMP is running, once we set it, like for example at 100% of the line rate, the particular flow will be receiving at 50%. Like we have like two flows, so each of them will be receiving at the max like 50%. So once it goes above that particular threshold value, we will note down the timestamp again. Here we can see that as there are multiple, like for example, here there are a couple of flows here. So each of them can reach at a different time levels. So here we will see like what is the maximum, like largest value, and we will note down the timestamp of this particular device, and we will measure the convergence between these two timestamps. So the difference between these two timestamps will provide us with the ribbon convergence value. So any questions regarding this methodology? Okay. So these are the results. These are the benchmarking performance results for the ribbon convergence when we advertise these set of IPv4 routes. As already mentioned, like by varying the number of routes, we can see that the convergence values also varies.
So these numbers, like based on which platform? Do you have
it depends on the devices, whatever we are using. We cannot mention here like what is exactly the platform, but yeah, we can benchmark on different set of devices, and the ISIC vendors are like the OEM.
So this is because you made the results here, right? So I guess
Yeah,
have a
because of the NDA, we cannot disclose the particular ASICs and all.
Can you at least because this is all control plane processing really, right? So what we really need to know is what was the CPU subsystem.
Sorry, Ben, I didn't get the question.
Well, I mean, to Jude's question, I mean, most of this time is going to be control plane processing, right? In which case, what really matters is what's the CPU, more so than what's the switching ASIC, wouldn't you say?
I see.
Yeah.
Yeah, we have to find that. I'm not sure if Kamal has that data handy.
No, actually.
Yeah, the thing is, I think the numbers has no meaning if we don't know the hardware, right? I mean, it could be a huge difference, you know, if you run a different hardware.
That is correct.
Yeah.
I mean, this is one of the sample sets that we have run on one of our switches in the inventory. But if you run it across the board, we do see some variance, and obviously with different platforms and also with different SONiC releases, we have seen different numbers. So this is just one sample set on how you expect to see the results. It's not indicative of any particular. We didn't call out the SONiC release or the ASIC or the platform yet because there are different results that we have seen across the board.
So
Yeah.
but the SONiC, at least we know, right? Which version was this? Do you have a?
Yeah, maybe Kamal, you can.
Yeah, this is the master branch only. This is the version from the master branch.
The master, like last month or the few months back?
A few months back, actually, like 3 to 4 months back, maybe.
Okay, got it.
Do you know if it's Debian or is it Stretch or Buster? Do you know? Don't worry, you can take it offline. It's just.
Yeah, sure.
I think the purpose of this test methodology, as you can see here, right? I think once we create this consistent benchmark test, we can I think can easily plug in different SONiC branches, different releases, and you can benchmark these performance metrics from box to box or ASIC to ASIC or different builds. I think the whole purpose here is to give the community a tool sets. Now you have a better way or a little bit easier way and consistent way to characterize these performance metrics. And I hope this shows actually effective methodology to meet that objective.
Yeah, this does open a different viewpoint. It's very valuable. So the interesting thing I see here is that from 1K to 8K, the convergence time increase is not 8 times, but from 8K to 64K, it's more than 8 times. And also from 64K to 196K, it's more than 3 times.
Yeah. So I think it's sort of, trying to give you like a black box view of all the stuff that's in the software, right? Like control plane all the way make into the database and then eventually hit your side layer in the drivers before it gets to the ASIC, right? Once it hits the ASIC, that's okay, right? But every vendor sort of their drivers sort of might perform different how they program their chips. So
yeah, no, that's definitely open up some interesting topics.
Yeah. Okay, so
I think it's about the linear, I think, roughly, right? The numbers. I don't know how accurate these numbers, but I think if you look at 1K to the last, I think it's about like half seconds of 1K, right?
So because it's not like only we did one time, we generally run it for like multiple times and we look at like what is the consistent value which we are getting and we take out like the average of like the same level. So this is kind of we observe by running it like for example 5 times in this case, we run it and then measure it like whether we are getting consistent results or not. So in this particular case, for this device, yeah, whatever we had tested in-house, so like we have these values. And again, yeah, it depends on different chip vendors and all those stuff.
But I think one other thing that's interesting is like if you look at these like 196K stuff, right? Like it's really like the trying to stress the maximum and stuff. What would be interesting is if we get like the network operators, the people who actually deploy it, get some feedback on sort of what type of, you know, like number of routes they have in their system, in their network, right? And that's really what they're interested in, not so much on the max capacity and stuff, right? So you could spin this whole benchmark multiple ways for people who are developing DUTs and NOS, and you know also help the end user, right, who deploys it. So because some of them may not have 196K, right, in their route cache or whatever.
Okay, so next go to this next loss test case. So this is the ribbon capacity, means the route capacity test. So here we will be doing the same above methodology. We will be applying the same ribbon convergence test methodology, and we'll be running it in a linear fashion so that we know the maximum route capacity of a particular device. So in this case, these are the sample results, and we can see like 196K is the maximum number of routes which it can handle, and once we go beyond this particular value, we will see the loss. So this way we can figure out the maximum route capacity of a particular device within a network. So we started automating the first test case for this test plan, and the script has been using the same open traffic generated data models that are being used in the RDMA and PFC test cases. The script uses a Python library named as Snappy that provides a Pythonic interface to this open traffic generated data models. To recollect, the open traffic generated data models are defined using OpenAPI v3, which are vendor neutral and take a declarative approach to building configs. The Snappy library is also open source, and both these are like available on the GitHub right now. And once the script is ready, we will submit a PR for review and include it into the SONiC management tree. So next call for action is to include, this is for a single DUT scenario. Next is we want to make sure like we replace those simulated ones with the real DUT for a system test scenarios. And also like, for example, yesterday, if you guys have attended the SONiC community meeting, so there also the topic came in like how to use BGP and ECMP in a VOQ type of chassis. So we can also directly take this particular test plan and do testing there as well on a chassis based DUT. So that's it. And any queries here?
Is there any difference from this test case to the above? I mean, for example, 196K, right? You have 5 seconds difference. Is that just a test variance, or it's you have different?
Yeah, kind of test variance here.
Okay. So I remember like in your slides, you're talking about many more test cases, right? Like
yes.
Yeah,
we will. So. Yes. We will add all these cases here just for this purpose, like just to know the test methodology and if they are correct, and if we want to get a review on these cases, just we wanted to highlight on those 2 cases just for a sample cases, and we will be adding all these to this particular test plan.
So what is available today? I mean, like, is that the remote link failures the one?
These sample results show regarding this, the remote link failure, and we already started automating this particular case. So once that is ready, we will upload it, upstream it to the community, and remaining we'll start working on these cases.
So deployment is done, right? For this
deployment is done. Yeah.
Okay.
Yeah, we like to kind of show these test methodology and make sure this is effective and kind of worthy for the community before we start automating the rest of the test cases. I mean, today you can see these are the key methodology, and everything listed in this table here is just the variance, right? So if the community think this is effective, this is needed, we can accelerate and upstream as many test cases as possible. And I was really appreciate the feedback here. I think we did learn a lot today. So if you think we are heading the right direction, and then we'll consider a green light on the team, and we can start contributing, investing more in this test category. All right, sounds like this is
just a quick question. I mean, like about the hardware requirements. I mean, other than the chassis, I mean, do we need some special software on the XCS side, or is this like something included, or how this is done, like a simulation, all these things, right?
Yeah, this is just a regular IX network BGP emulations.
Okay. So as long as you have IX network, it should be okay?
Yeah, it's very typical IX network setup.
Okay.
Any other questions?
I think we do have a few minutes left. I'm just wondering if you guys like to see, we also have a plan to upstream ENVO BGP conformance test. I think that's another area that could help and test and increase the BGP test coverage, specifically for testing, the new protocol stack you will be integrating into SONiC. Ian, I'm not sure you want to do that. Do we have time, or you want to finish?
President, do we have enough time? We have 30 minutes left. Do you want to do it now, or do you want to do it next time?
Depending on your schedule, your agenda, you sometime the next meeting, or we can give you a full update.
There might be a half an hour or so next time. It would be more than 30 minutes for sure.
Sure.
That's up to you.
But Dina, you talk about upstreaming test cases, right? But Anvil is licensed software, is it not? Are you going to be upstreaming the Anvil license free?
Well, I mean, it will be like similar to IX network, right? I think you'll bring your own license to run IX network, and
Okay.
we upstream the automation test cases. The same thing with ENVO. You're bringing your own ENVO license, but what we're going to be upstreaming is the entire full automation test suites to configure SONiC DUT, to execute tests, to collect results, and it's all going to be part of the SONiC management Docker deployment. Right? That's the part we're going to contribute. Right? So in that case, you could make the ENVO BGP run as part of the SONiC regression, or anybody change FRR stack, they can run the BGP test to make sure they're not breaking any BGP conformance protocols.
But you need the licensed software to do that. Is the point?
Yes, I think that's the part we.
Yeah.
Our contribution is the automation part. Make it easy. You just set a few parameters and run your PyTest, and it's all done.
So just a quick thing. I think the like N-way ECMP, right? I guess is that configurable, right? Eventually, because It really
Yes.
depends on how many ports you have, right? Like physical
Yes,
port.
yes. Yeah.
Correct.
Okay.
And you can even simulate how many T1, how many T0 switches in this simulated topology.
Yeah.
Right?
Well, what I'm saying is that I think that should be part of your automation configurables.
Yes,
people can actually
definitely.
modify. Yeah.
It will be part of yeah. It will be a variable where we can set it here.
Okay.
So think you're going to talk about the envelope next time?
Yeah, it looks like maybe we should give a little bit more detail next time.
Sure. Yeah. So we have 5 minutes now.
Yeah, exactly. All right.
All right. Thanks all for your feedback and for your time.
Yeah. Thanks. Okay. So if there's no more questions or comments, we can give 10 minutes back to everyone. Thanks everyone for joining
Yeah.
today.
Thanks everyone. Yeah. Bye.
Happy Chinese New Year, everybody.
Thank you.
Oh yeah, happy Chinese New Year to everyone too. I don't know how many of us are going to observe that. It's really North American. Yeah. Anyways, happy Chinese New Year, everyone.
Happy New Year. Bye.
Thank you. Bye.
Bye bye.
Bye.